Hey everybody, this is Alex Merced, and welcome to another episode of this Apache Iceberg crash course, where we're going to be talking about ingesting data into Apache Iceberg with Apache Spark. And this is the 9th episode of our 10 session series, brought to you by Gnarly Data Waves and Dremio. And basically, again, just as a reminder, as you learn everything in this course, you can learn even more by getting a free copy of Apache Iceberg, the definitive guide, which you can get by scanning this QR code right here. Now, you can also subscribe to make sure you never miss any new content from Gnarly Data Waves by heading over to youtube.com/Dremio and subscribing to the Dremio YouTube channel, which also gives you access to all the other cool content that we put out at Dremio. But also, you can subscribe to the Gnarly Data Waves podcast feed on Spotify and iTunes, and always find the latest and previous episodes over there at dremio.com/gnarly-data-waves. If you have any questions about Apache Iceberg from this series, just head on over to community.dremio.com and you can go post your question in the Apache Iceberg category. And basically today we're going to get hands-on with Spark. So if you want to follow on in this exercise, and do this at home after the session's over, what you can do is you can scan this QR code. This QR code will actually walk you through all the steps to do the exact same exercises that I'm doing within this video series, which basically will walk you through doing several different things, such as, first off, setting up Spark. So let's go set up Spark, and I'll see you on the other side. Hey everybody, let's get started creating our local environment so we can get hands-on with Apache Spark and Apache Iceberg. Essentially, what I'm going to do is be working off this guide, which you can find at this URL right here. Also, probably the URL will be provided to you within the course or video description in which you find this video. But let's begin. So essentially what I'm going to do is I'm going to be using a tool called Docker. Docker is going to allow us to kind of run, to put it simply, sort of imaginary computers within our local computer environment. Okay, and we can basically simulate a whole environment of like multiple computers running together right there from our little laptop. Now you're going to want to make sure you download Docker. Head over to docker.com where you can download Docker and be up and running. But once you have Docker installed, which is again just a couple clicks, then what you're going to want to do is we're going to scroll down here and we're going to find this configuration file right here. We're using something called Docker Compose. So Docker Compose allows us to describe the environment we want to create using simple YAML, which stands for yet another markup language. So here we have YAML. Again, you don't have to write any of this. I've already got it all nice and laid out for you. So all you have to do is copy and paste it and head over into your favorite text editing environment. I'm using Visual Studio Code. It's my favorite text editor, but you could be using any text editing tool to edit the files that you need to edit. So me, in just some sort of empty folder, so it could be literally anywhere in your computer, I'm going to create a file called dockercompose.yaml. And I'm just going to paste the contents of this file right here. Now, in this case, what I'm going to do is I'm going to start up the environment. And the way we would do that is we type in Docker Compose. That's going to essentially say, hey, we're using Docker Compose, which long as, and again, make sure that your terminal, so in this case, my terminal environment is opened and exists within the same folder that I have the file in there. So I can confirm that by two ways. I can say pwd, this is print working directory. So I can see, hey, this is in the right folder where I have today's lesson. And I can also do an ls just to make sure that the Docker Compose file is in the folder, and I can see, yes, it is in that folder, and I can clear that out using clear. And again, I'm using a bash or Zush terminal, which should be default if you're using Linux or Mac. If you're using Windows, I recommend using a Windows subsystem for Linux environment, so that way you default to this type of terminal, but the PowerShell commands aren't all too different. Okay, cool. So basically what you do is you do Docker Compose up. Now this would be all fine and good, but when I do this, it's going to put all the output for all three services that I'm running right here into this terminal. I don't necessarily want to do that. I don't really need the terminal output specifically for Nessie and Minio. Okay, so what I can do is I can run those two in the background. And the way you do that is I can specify their service names. So in this case, in the document, in the YAML, I specified that the Nessie service is called Nessie, and the Minio service is called Minio. Okay, I specified it right there. So I can say, hey, Docker up, I'm going to do -d, which is going to mean run this in the background. Like I don't want to see all the output in the terminal. And I'm going to say, hey, I'll do that for the Minio and the Nessie service. So what that's going to do is going to start up those particular services. So it'll just take a moment to do that. And then once it frees up, we are good to go. And there, that's done. Okay. Now the Spark container, okay, which the server, that service is called Spark, okay, so that's what I named it there, that I do want the output for, and you'll see why in just a moment. So I'll just do Docker, oh, nope, that's not good. Okay, undo that. Docker compose up no -d, because I do want to see the output here. I'm going to do Spark. So I'm just starting up the Spark service. That's the only service still needed to be started. Okay. And now that's going to basically pull down that container. Okay, so right now I don't have that container on my computer. So right now it's downloading it, and then it's going to set it up. So I'm going to basically pause while that downloads. So now once it's done loading, you're going to see some output like this. And this is why this is important. Because what we're going to want is, see right here, it says like to access the server, copy and paste one of these URLs. What we want is this URL right here in particular, the one with our local host, so 127.0.01. Okay, that particular IP address always means the laptop you're on or the computer that you're on. Okay, so I'm going to want to copy that one. And I'm going to want to put that in my browser. And that essentially, and the reason is you need that token that's at the end of the URL in order to access the notebook server. So now I have Python notebook. This Python notebook server is co-located with Spark, so you're able to run Spark code against it. So now I can easily just create a Python 3 notebook, wonderful, and begin writing Spark code. Now I've already provided you some basic Spark code to kind of do the initial setup. So we'll kind of get past all this text over here and get right down here. Okay, and if I copy this code over here, now basically this is your basic sort of startup Spark code. Essentially what you want to do is you create a configuration. This configuration is essentially all the settings for the particular Spark session that's running. Okay, it's basically saying, hey, I'm creating a new session with Spark where I'm going to send Spark instructions. During this session, basically these are the ways I want to tweak this session so that's going to affect how all these instructions I'm going to give Spark are run. Okay, so you can see here we create a Spark configuration object, and then you see here we're going to do set a bunch of configurations. So we set the packages. So these are going to be the particular jars that need to be downloaded. So this basically tells the Spark cluster. Okay, so again, there's our Python code, which theoretically, if I had this Python notebook running on a different machine, the machine where the Python code runs versus the machine where the Spark processes run are two different machines, and that adds a little bit of a level of like having to think through like, hey, what are you doing where? So having them co-located on the same machine just keeps things a little bit simpler. But essentially what it's doing is it's going to send instructions to wherever the Spark cluster is and say, hey, in order to do the things that you're going to need for this session, you're going to need these Java jars. Okay, so think of these are Java libraries that are needed to do the things that we're going to be asking Spark to do. Okay, so basically this sends instructions of which jars to download. That's already kind of all set for you. And also we're going to be using some custom SQL language. So these are called SQL extensions, and they're available in the libraries that are available to Spark, which again, we just specified in the previous packages section. So I say, hey, there's these extensions that I want you to have enabled for this session. Okay, and that's this right here. Now, again, in Iceberg, we want a catalog. Okay, so we're using a Nessie catalog, but Spark doesn't automatically know that this catalog exists. I have to tell it the catalog exists, give it a name, and then give it all the configurations for how to talk to that catalog. So in this case, we do spark.sql.catalog, and then you can give it some name. In this case, I'm giving it the name Nessie. It doesn't have to be Nessie. It could literally just be whatever name you want. But then long as it has to be the same name every time, and then you're configuring that same catalog. You can have multiple catalogs. Won't go there right now. But as you see here, first I'm saying, hey, we're going to have a new catalog called Nessie. It's an Iceberg catalog. Now Nessie is a separate server, so I need to point it to where that server is. That's this Nessie server URI, which we're going to have to change in a moment. Just because for some reason, like the DNS. So basically what happens is that usually this would work. So we'll see how it says Nessie. Because usually the way Docker works is that each of these services are available using the name that I specified in the Docker compose file. So, because basically what it is behind the scenes, Docker is setting up what's called a domain name service that matches up the IP address of each of one of these services to the name that I gave it. So Nessie, Spark, Minio. But for some reason, the DNS doesn't always resolve quite right for this in this particular setup. In Spark specifically. So usually what I'm going to do is I'm going to use IP addresses. So we're going to have to find IP addresses for these to the Minio machine and the Nessie machine, which we'll do in a moment. Okay, so we're going to have to edit those, and we'll update those in a moment. Okay, but essentially these variables right here just have all the details. Okay, and we're going to be using a bucket called warehouse, which we actually have to create. That bucket doesn't exist yet. So what I'm going to do is I'm going to go in a separate tab, open up Minio, because again, we did spin up Minio, and I'll be able to find that at localhost 9000. Okay, and then the username and password, assuming you didn't change any of the settings, should just be admin and password. If I can spell password correctly. There we go. And all I need to do is make sure that there's a bucket in here called warehouse to manage my settings. Okay, a bucket is just basically a place where I can save files to keep it really simple. Okay, so now I have a bucket, I can save files there, and then so there, that's specifying that. So now what I need to do is just make sure that these two URIs are pointing to the right IP addresses. So in the settings, I do have the directions for how to do this. Let me just go see where I put those. Yeah, here we go. So here's how you'd find the services. So first we need to figure out which network we're on, okay, which is going to be a network generally by the name of, right here, you see how I have a network name. There should be a network that's by that name. So what I'm going to do is I'm going to create another terminal because I don't want to affect this terminal. It's running my stuff. So I click plus. That's going to open up another terminal session in a separate window. And I'm going to run this docker network ls command. Docker. Okay, and you can see I can see there's that network. Okay. So now what I want to do is I want to inspect that network. So I do like docker network inspect. And then I just look for that particular network. There we go. Okay, and then I can just hit enter. And you'll see here's the details for that. So now like here in this section called containers, it's going to show me each container that's in that network. So I see there's Nessie, there's Minio, and there's Spark. What I need is the IP address. So I need the IP address for Nessie. So I'm just going to copy that right over here. And again, it's not always going to be the same. So every time you do this, those IP addresses may change, which is why you have to do this. Okay, so I'm going to copy that over to Nessie because Nessie is going to be this. Okay, and now I need to double check what the IP address is for the other one. Okay, so for Minio, it's this. Okay, because they're all on the same network. So they can all see each other. Just got to make sure you're pointing them to the right IP address on that network. Oops. Okay, I just want to paste it over that specifically. There we go. Okay, so now these should be pointing to the right IP addresses. So that means, hey, when I say, hey, talk to the Nessie server, it should be pointing to the right URL. Okay, this is just referring to which branch because Nessie supports branching. Okay, we're not going to get too deep into that this very moment. Okay, I'm using the default Nessie settings, so which have no authentication. So authentication type none. We're using an Nessie catalog. Minio URI, that's going to be the where to talk to Minio. And we're going to have here which bucket we're connecting to. And again, these are all being served from these variables right here. And that's it. And then basically what this does is sets up the configuration object. We then create a new Spark session, which is going to communicate with the Spark server and saying, hey, we're creating a new session for instructions. Use these configurations that we created. Okay. And then we can start sending Spark instructions. In this case, we're going to send it some basic SQL. We're going to create a table called example. Okay. We're going to insert into that table. And then we're going to query that table just to make sure that this works. This is just to kind of make sure that this is all working. So I'm going to just put my cursor all the way up here at the top. I'm going to hit run to run this cell. And you're going to see some output like right down here. So basically what it's going to do first is you'll see here that it's finding all those jars that we specified saying, hey, we want these libraries. So it's now downloading those libraries from Maven. Maven is where Java libraries are generally stored. So it's downloading them. And you can see all that kind of being explained here in this text. And once it's downloading all that, the Spark session should start. And again, this should only take so long the first time you start the session. So if I were to restart this notebook, it won't take as long. But yeah, so it's going to do that. Okay, once it's done downloading that, we keep reading through. It's resolving. Spark is running. So that looks good. Okay, so far all this output is looking the way it will look. And then that means it created the table successfully, that output right there. That means it inserted successfully. And then there's the result of our query. So everything is 100% working just fine. We are good to go to continue with this. So that ends the setup of our Spark environment. Okay, so now that we've set up Spark and we have that running in our local environment, the next step would be to actually create some Iceberg tables. So let's talk about that. So now that our setup is all complete, okay, do keep in mind we have already created an Iceberg table just in our basic setup. So just to kind of show you that, if I go back to my Minio console where I set up the bucket, if I were to refresh this, I can see now there's objects in my bucket, okay? And actually I want to go to the object browser to actually look inside. And I can see, hey, look, there's that example table. So there's a folder for that example table we created. And in there, I can find the data. So here's all the Parquet files. And if I go back, I can see the metadata, all the metadata for that Iceberg table. So I can see, hey, look, it created the thing that I expected. And I can see those files on my data lake. And the cool thing is I can then connect other tools to that Nessie catalog, and they'll be able to kind of interact with these tables. But let's show you a couple different ways to create tables. Okay, so we just created a quick table through SQL, but let's kind of go through some of the different ways you can do this. Okay, so creating Apache Iceberg tables. So I'm going to show you a couple different like code clips and we'll walk through them. So first we'll show you how to use a data frame. So generally when you're working with data, you generally have two different main ways to work with data. Okay, and this is like tabular data. Data, as you know, is tables. Okay, and that's either SQL, where you express things declaratively through SQL and say, okay, hey, this is the end result that I want, and you describe the end result, and that it goes then creates that end result for you. That's declarative programming. Or you can use imperative programming, where you describe the steps you want to be taken, and that's what you use a data frame for. So a data frame is a data structure that saves the information as unique columns, and then you can basically describe what you want to be done. Okay, so here's an example of us using the PySpark data frame approach. So I'll just copy this code over into our notebook. Okay, so I'm importing some of these SQL functions because I specifically want the current timestamp. Okay, so what I'm going to do here is I'm creating a data frame. And again, a data frame is essentially an array of columns. Okay, so here you see here there's data. So there's like 1 record, 2 record, 3 records, each of them with the ID of that record and the name of a person. Okay, and then here we have an array of column names. So then we're going to use this Spark create data frame function to create a data frame. Okay, and we're going to say, hey, this is the data of the data frame, and then these are the column names, and then it's going to reconstruct that as a data frame. So under the hood, what you do is you would see an array of columns or a list of columns. And then we're adding an additional column called timestamp that includes the current timestamp of when it was inserted. So this creates a data frame. This creates the data frame, but we want that data frame to be an Iceberg table. So once we have a Spark data frame, well, data frames in Spark have a function called write to that allows you to write to a target format. So in this case, I just say Nessie and Nessie dot, because Nessie is the catalog. So if by saying Nessie, it knows that it's an Iceberg table because Nessie is an Iceberg configured to be an Iceberg catalog. So I'm saying, hey, in the Nessie catalog, save it as data frame, df underscore table is the name of the table. Okay, and then and then this function then does triggers the creation. Okay, and then now I can then query that table. Right here, I send some SQL to Spark to query that specific table to show you that that worked. Okay, so let's run that code. Okay, so that's running. And yeah, it worked. So I was able, my select query worked. I was able to query that Iceberg table once it was created. Let's just double check that I got created. So now if I go back to my warehouse bucket and look, there's the DF table And there's the data and metadata. So far, so good. This is working the way we expect it to. Now, again, I don't have to use data frames in Spark, but data frames can be useful in certain situations. Depending, I might load data from a CSV or a JSON file into a data frame using Spark and then want to write that to an Iceberg table. That's one way to do it. I could also just use SQL. Okay, so here I'm just using plain old SQL to write my table. So in this case, we're saying we're just writing some SQL, so normal SQL. Okay, you might have seen 1,000 times. Okay, specifying the different columns that are going to be in that table. But notice that in Spark, we have to use this using Iceberg clause. It has to know what type of table it's writing, because there's other types of tables that other catalogs may support, whether it's like Apache Hoodie, Delta Lake, things like that. So you have to specify, hey, what type of table it is so it knows how to write the table. So this using clause is important, specifically in Spark. Okay, now once I do that, that creates a table, but then I have to put data into the table. So I use an insert statement, just like you would in any SQL context. I insert some data into the table, and then I can query the table. Okay, so you can see here, I'm going through those steps. I can then just put my cursor over here, run the cell. Let's just make sure that it's all successful. And yeah, it's successful. We'll create the table, and at the end, we see the result of querying that table. Okay, so there's different ways you can create a table. Okay, so I'll see you all in the next one where we'll talk about putting data into a table. Okay, so now that we got some Iceberg tables, let's put some data into those Iceberg tables. And again, the beauty of this is we can use these processes to then just take data from any source that we can connect to Spark. Tables. Let's talk about inserting data into tables. So again, just like before, we took a look at the data frame approach and the SQL approach, and we'll do the same thing here. So what I'm going to do here is we're going to use JSON data and show how to kind of inject JSON data into an Apache Iceberg table using a data frame approach. So I'm going to just take this code snippet here, and we'll walk through it, bring that into our notebook, into a new cell, and let's walk through it. So I'm going to bring in the Python JSON module, so that way I can work with some JSON data and turn it into JSON objects. I'm going to bring in the column function from PySpark, so that way I can create columns. So basically what I'm doing here is first I'm creating a JSON file. So literally what I'm going to do here is work with the JSON file. So first I have to create the JSON file. So here I'm creating the data, which is just going to be a list of dictionaries. Okay. And then what we're going to do is have a file path to where we're going to save the JSON file. And then I'm going to open the file and then literally just dump the data that we just have in that list right into that file as JSON. Okay, so now we have a JSON file written into our system. I'm then going to go read that file. So here's how I would read a JSON file into a data frame. So I use this spark.read.json, tell it, hey, this is where the JSON file is. And now I've created a JSON data frame from the JSON file. And again, I want to add that timestamp column. So here we add our timestamp column to our JSON data, or the data from our JSON. And then here we're going to see the result of that. So you're going to see a print of the data as it is there. Okay. And, basically what I'm going to do is I'm going to add a print there just to make this a little bit clearer, saying, okay, data loaded from JSON. Okay. Then what we do is we're going to create a sub namespace in Nessie. So the idea is that we don't necessarily want everything to be nessie.this, nessie.that. We're going to want maybe to have it broken up into like different like databases and different namespaces. So we're going to say nessie.db. So this represents sort of like one place to store tables within our Nessie catalog. So, we might do this to have different databases like a marketing database or whatnot. So we'll say nessie.db. That's the namespace we're creating if it doesn't already exist. Okay. And then we can use SQL to create a table in that namespace. So we're going to create a table in there. And then we can use the write to command to then write to that table. Okay, we're appending the data. So in this case, we're assuming that the table already exists. Because again, we're not creating a table. We're assuming the table already exists. And how would I add that data to the table? We use this append function. So notice, instead of saying write.to.create, like we did when we created the table, it's .append to append or add the data. Okay, and then we'll query the data. to show you that it was all successful. Okay, so if I run this, we'll let that run. So you can see here, it was successful when we loaded the data from the JSON file. So that's from the JSON file, but then it looks exactly the same when we queried it as an iceberg table. So overall, success. Okay, so again, what we did is we created the table before we added the data. So in this case, we were adding or appending the data to the table. Okay, now let's see what this would look like with an SQL approach. So again, I'll go copy over the code into a new cell and we'll walk through it. Okay, so once again, we're going to create some sample data. We then save it to a JSON file. We are then going to load the JSON file. But in this case, we want to use SQL. How is the SQL going to know that the data frame exists? So there's this function, create or replace temp view, that allows you to create sort of an SQL name, or a name that the SQL will recognize as a table, but it's really a data frame. So in this case, we're saying, hey, we're going to pretend that this data frame is a table called JSON table. So now going forward, I can now go in there and use that in my SQL. So here, what I'm doing is, again, I am adding that timestamp column. And so I'm saying, hey, select ID, name, create a timestamp as TS from JSON table. So I'm creating it from that. So you notice how I can use JSON table in my SQL. And then I'm creating a new table called JSON table casted. So that's with the additional timestamp. I'm creating that DB namespace, assuming it wasn't already created. We did. So that's why it's important to have this if not exists clause in there. So that way it doesn't throw me an error if it already existed. Okay. Then I create the table because, again, we're appending data. So I'm going to create the table first. So right now the table has no records. And now look what I do. I do an insert into, but instead of doing an insert into and then specifying each record, I use what's called an insert into select. So I say, hey, I'm inserting into this table the result of this query, select, and this query just basically gets all the data from that JSON table casted table. And then basically those become the records that are being inserted into this table. And again, because it has a matching schema, that's going to work all fine. And then we'll query that table just to make sure that that was successful. So let me just go put this right up over here and hit play. Let's let that run. And success. Cool. The data was inserted and we queried the iceberg table, and that was successful. Okay, so overall, pretty smooth. Okay. Now, one more example. This is going to be this merge into example. Okay, and just so you can see just like the result of this, let me just actually show you the table so far. Now notice, now there's this DB namespace. So again, every table I've created in the DB namespace is now inside of here. So again, these namespaces just allow you to kind of organize your data a little bit better. So now I know that, hey, my tables for the DB database is in here, and then I can create different sort of spaces where I create tables. And you can see the example tables in there. So I'm going to paste that merge into SQL in here. And let's want to watch how it goes. So again, we create some example data. We save it to a JSON file. Okay, we create our temp view as we did in the previous one. Now, again, the difference between like a merge into, which is what we're going to be doing in this, is that instead of inserting data, what we're doing is we're taking two tables and saying, hey, this table A is the table I want to update based on the records in table B. Some of that data I want to update, some of that data I want to insert, and merge into will kind of allow you to specify what the logic is for doing that. So in this case, what happens again, we're going to create two tables. So here we create an empty table that has no records in it. Okay. And we're going to insert, some of that data from the JSON table in there. Okay. So that creates sort of like the initial data. Okay. Then what we're going to do is we're going to create some additional data that we want to add. So this is going to be the data that we want to like merge into. So we create that, we do the same thing again, create a JSON file, read the JSON file, just again, assuming that we're working from JSON files, because you might have some sort of system that dumps data as JSON or CSV for you, and you're trying to move that into Apache Iceberg. But basically, once I have both tables in place, Okay, then I can do something like this. So merge into nesty.merge example. So that's the target table. So that's why T for target. Okay, that's the table we want to update, the original table. And then this is the source of the new data, the staging data. So we're going to call that S. And we're going to say, hey, match them based on where they're the same. Because again, if we take a look at here, some of these IDs are the same. So 1, 2, 3, or 1, 2, 3, 4. So in the ones where the IDs are the same, it's going to update. So again, if I take a look at the original, it has Alice, count none. And in the new one, it's Alice, count 1. So I'm going to want to update that. So it's going to say, hey, take a look at where they match. If the IDs match and the operation says delete, so in this case, we see here we have an operation. So it says in the operation, in this case, let's say this one says delete, it's going to delete that record. And t.count is null, because again, this might be like CDC data that you want to then go in there and then reconcile. And then in this case, if the count is null, then you're going to, and the operations increment, you're just going to add 1 to it. Okay, in this case, you're setting it to 0 because there's nothing to increment yet. And then in this case where it's not null, then you increment. And then in this case where there is no match, then you're going to insert that record. Okay, so basically that gives it the instructions on which situations to do what. So this way allows me to just in one big transaction to determine how I want to merge these two data sets together. Okay, and then I run that, we'll query it, and we'll see what the end result is. So the end result should be that I have 1, 2, and 4. 3 should be deleted. Okay, and basically IDs 1 and 2 should be incremented. And yeah, and then the number 4 should be inserted. So that's what we should expect as a result. So I'll run this. Let's see if this meets our expectations. And okay, so again, so here was the original data with 1, 2, 3. Okay, after we inserted it, here was like the staging data, the data we used to update it with. Okay, and then based on merging these two data sets right here, we end up with, so again, 1, Alice was to be incremented. So basically her count is now 0 because it was null before. Okay, Bob is now 6 because Bob's count was 5 before and it got incremented. So we added 1 to it. Okay, Catherine's been deleted because we see that there was the delete operation there. And then David was added because David wasn't in the original set of information. Okay, so those are different ways you can add data to an iceberg table using Spark. Okay, using insert into, or just using like a data frame, using that dot append function, or using a merge into SQL query to merge tables together to do things like upserts like this, where you might be capturing like change information in a staging table, and then you want to apply that to your table. And last, let's explore like how partitioning and how can you change partitioning within a Spark of an iceberg table. Now, oftentimes your tables can get pretty large, and scanning all that data every time you run a query can get really slow and expensive as your table gets bigger and bigger and bigger. So generally, a lot of times your queries aren't trying to scan all the data. They're oftentimes maybe very clear sections of the data. So imagine that you're talking about like voter data and you only want to scan voters of a particular party. So you can skip everybody else. So usually what you can do is you can do something called partitioning. This allows the table to be physically broken up based on a value, in this case, let's say political party. So that way, when I say, hey, I want to scan this particular type of voter, I'm only scanning that data. So a subset of the data for a much faster query. So Iceberg makes it pretty easy to do partitioning. So let's take a look at an example of partitioning. And we'll see what the result is when you write those files. Okay, so this will be our last code example here. Okay, so when I take a look in here, spark.sql, create namespace if not exists. Okay, so again, we're create a new namespace called partitioning example. We create a table, but notice that now when we create the table, we say it's partitioned by name. So in this case, we're saying, hey, anytime someone has a different name, they should be in a different partition. Okay, so each possible name value gets its own partition. Generally, you probably wouldn't want to partition by name. You know, you would want to partition by something with like a lower cardinality, meaning less unique values, because you generally want to group together lots of records in a handful of files in that partition for, again, quick scans. But as you can see here, we're then going to insert records. So again, we have 3 possible names, Alice, Bob, and Catherine. So the expectation would be you would get 1 partition for each name. Okay. Now, the cool thing about Iceberg that's really special is not only can you partition tables, but you can then you can change the way the table is partitioned. So you see here in step 4, we're going to alter the table. We're changing the way the table is partitioning. So we're saying, hey, let's alter this table, and we're going to add a partitioning field. Now notice that we use this little function here called bucket. Okay, these are referred to as transforms that are built into Iceberg. These are special, unique Iceberg features. They make doing typical partitioning patterns that oftentimes would result in a lot more work, make them a lot more easy. So in this case, I'm basically just saying that, you know what, the timestamp field, there could be infinite timestamps, right? Because every millisecond is a different unique value. So in this case, let's just break up every possible timestamp into 4 possible buckets. So it's going to take the value, put it through a hashing function that will only have 4 possible results based on the number that I put in the function. And basically every timestamp will fall into one of those buckets. So if I were to scan for data within a particular timestamp, it will then figure out, hey, which bucket does that belong to, and then run the partitioning value there. This would be probably useful if I were like partitioning by name, because then I can break up all names into 4 buckets instead of every name being their own individual sort of partitioning bucket. Okay, so I'm going to insert some more data so we can see the difference in how the data gets written. And then we'll create the table. Okay, now again, the question thing, the difference here is going to be how the table gets written. Basic partitioning is a write time thing in the sense that, hey, when it writes the data, it makes sure to separate the data based on how the data is partitioned. Okay, and again, the cool thing about Iceberg is that you don't have to rewrite the whole table to do it. So we've written the data. Let's head over to our Minio bucket. So I'm going to head over back to warehouse. So here's our partitioning example namespace. And if I go in here, there's data. And when I take a look at the top level, I see the partitioning based on name. Again, because that's our original partitioning scheme. We never removed it. We just added another one. So some of the original, so if I go into Alice, I find the data file right there. And that's just going to be a 1 record parquet file with Alice in there. Okay, oops. Now let me go back to here. We'll go with the Bob. Bob, again, was one of the original 3 that got written. Okay, Catherine. That's one of the original 3 that was written. And then I go to David and Eve, the 2 that were added after we changed the partitioning. Now let's take a look at how this looks differently. So when I go in there, I don't find the data file anymore. Instead, there's another folder because we added that other layer of partitioning for the bucket, and this was hashed into bucket 3. And then there we find the data file. Okay, but notice that both categories of data exist and they can be queried just fine. Okay, this is not something you can do in other table formats. The minute you switch from partitioning one way to another way, you have to rewrite all the data. Iceberg doesn't require that, which gives you this nice level of flexibility. Okay, and again, there's other partitioning transforms other than bucket. There's truncate that lets you truncate down to, like, say, hey, I only want to partition based on the first letter of the name. You can do year, month, day, so that way you can partition based on the timestamp value, but on a more higher level, like based on the day of the timestamp or the year of the timestamp and whatnot. So you have some flexibility in how you partition, and it's pretty easy. So it's pretty easy to set your partitioning initially, and easy to set your partitioning to change it later on using alter table statements. So that's a quick foray in getting hands-on with partitioning in Apache Iceberg.
Let's go through the questions. Okay, so when setting up the Spark config, is there a good methodology reference for identifying the required jars? Now, I have written a blog on this. On the Dremio blog, there is a blog about configuring Spark for Iceberg, because this is kind of confusing. There's so many different sort of scenarios and different jars you may need. This has gotten simpler, okay? Generally, the one thing you'll always need is the Iceberg jar. You always kind of want the latest Iceberg jar. Then you need something for the particular file system you're writing to. So this could be maybe Hadoop jars if you're writing to Hadoop, AWS's toolkit, or SDK if you're writing to S3 or S3 compliant layers like Minio. Maybe there's a couple different libraries for GCP and a couple different libraries for AWS. All of those are outlined in that blog, but also I think the Iceberg documentation has become a lot more robust in identifying these jars in the documentation. in the specific sections for those particular like clouds. So there should be like an Azure section, a Google section, the AWS section. Each of those will tell you which specific jars you need for those file systems. And then there's Nessie. So if you're using, as I talked about catalogs in the past, each catalog kind of had their implementation. So in this case, for like Nessie, you would have to download that separate jar for Nessie. That's mainly for the SQL extensions. You want to do like the branching and the merging natively right there through SQL. But nowadays, Nessie does have a REST catalog implementation, so you can use the REST catalog to connect to Nessie. So that in that scenario, you do not need to specify the Nessie jar or the Nessie SQL extensions. You won't be able to do like the branching directly in your SQL in that situation, just because the REST catalog specification doesn't support that currently. But you are able to specify sort of what your initial branch is. So usually what you're going to do is you'd create your branch ahead of time if you're going to go this route. And then what you do is in your configurations for the REST catalog, you specify, hey, this is the branch that I'm operating on. And then they would just take all your instructions directly from that branch. But when you're using REST catalog, in that case, you really only need the Iceberg jar and whatever jar you need and whatever jars you need for the file system you're writing to, and that's it. Because everything, all the logic for how the catalog works is on the server side, and it's just basically Spark will just be making REST calls to your catalog, and then the catalog kind of handles all the implementation details behind the scenes. But that's a catch when you with Spark and a lot of these other open source tools. They're very flexible. They are open source, and that flexibility comes with the need for configuration. And the configuration can be a little complicated as you get familiar with it. Now, when you're using like sort of tools, let's say that kind of wrap around these kind of things, like Dremio. With Dremio, you would just choose your source. As you'll see next week, you just choose your source, you configure your source, and it kind of just works. So again, next week's episode, you'll actually see a lot of the same exercises we did today, but see them within Dremio, so you can kind of see the difference and the beauty that Iceberg can just work with different tools pretty easily. So that'll answer that question about the jars. So let me just mark that as answered. Okay, the process for ingest data in stream is the same. There is there is no difference as far as how you configure the catalog. There are different functions within Spark streaming that you would use. So essentially, but the principle is the same. Like you wouldn't necessarily do anything different than you would do if it wasn't streaming. You're just going to be using the Spark streaming primitives instead. There are some configurations built into Iceberg for Spark streaming to make to enable some of the optimizations you might want. Those are detailed in the Iceberg documentation. If you download the Apache Iceberg guide, those are also detailed within the Apache Iceberg book. I recently have come out with some more articles relating to Iceberg streaming. So if you go over there to the Dremio blog and the Dremio Medium blog, you should be able to find those resources. So most recently, I came out with a CDC for Iceberg article that kind of targets how you can implement different types of SCDC patterns with Iceberg. And then I've also written previous articles on using Flink, using Upsolver, using AWS Kinesis, and other tools for ingesting directly into Iceberg. So all of those can be found on the Dremio blog. And then I've also recently on the Dremio Medium released an article called The Ultimate Resource Guide for Iceberg, where I've kind of categorized all these articles that I've written in the past. So that way there's just like one nice list of everything. You can easily that's all categorized. So you can find all the tutorials that you'd like. And again, you can find that at the Dremio Medium. Just go to medium.com, subscribe to the Dremio Medium blog. It's pretty cool. I just actually published an article about using PyArrow in Python for your consumption. Okay. Cool. So mark that one as answered. Would love to see a follow-up to alternative Spark ingestion. Yes, I've written a lot of articles on Iceberg ingestion. Again, as I mentioned, I've covered Upsolver. I've covered using I still need to write an article on Iceberg because PyIceberg has added new write functionality, so I'll make sure I do that. I'll try to see if I can do that this week. I've also written on Spark, Flink, and several other tools. So if you go to the Dremio blog, you'll find plenty. Again, if you read that Ultimate Resource Guide article, I have a lot of that. And then next week's or not next week, but our final lesson for this course, which I think is on October 29th, will feature us doing this exercise with Dremio. Okay. So you can see an alternative scenario, and you can see that when you see the difference is sort of in the ease of use when you're using a tool like Dremio, which is built around being easy to use. Do limits exist in the number of partitions in a bucket or other? I don't think there's any hard limits like coded in as far as how many partitions you can have, because there's scenarios where any number could theoretically be appropriate depending on the how big your cluster is and what the size of those partitions are and the types of queries you're getting. But generally, you want to be careful about too many partitions. Actually, there's another thing I just recently wrote an article on kind of ways to simplify your partitioning. So here's like generally what happens. Like oftentimes you're ingesting your data periodically or streaming it in there. So oftentimes naturally you want to kind of reach for that historical partitioning, that day, month, year partitioning. The reason why it's real from a table management point of view, it's really easy to know when to compact when you do it that way, because basically, hey, if your data is being ingested and partitioned by day, then you know at the end of the day, if I run compaction, that data for that day is optimized as much as possible. And with Spark and Dremio, you don't have to rewrite the whole table. You can always just rewrite a particular partition, and that gives you so basically it creates a really nice cadence and makes answering the question sort of how you maintain your table pretty easy. But oftentimes, what happens is that you also have other queries that you're optimizing for that are based on other columns. Okay, and you want to optimize for those columns. So you try to say, hey, partition by like day and this. Problem is now you have a day partition for every day, and each of those days there's partitions to a bunch of sub partitions based on that other column. And this can create way too many partitions with way too small files. So you're increasing, you actually end up slowing down a lot of your queries because they're having to open up so many different small files. Okay, now a nice thing about this, if you're using something like, oftentimes if you're not using Dremio, probably your solution would be something to you'd have to kind of create some sort of hybrid column. So maybe you create like an additional column that is a mix of the date and that the value of that X column, and then use like a bucket partitioning and say, hey, I want to bucket these values into this many partitions, so that we don't have too many partitions, but it's still kind of partitioned out. It still creates some questions regarding how you're going to do maintenance, but you should still make it that should be doable. With Dremio, this becomes a bit simpler because you can just keep the original table as just purely a date partitioning thing. So that way it's just like, hey, every day run compaction, pretty simple. But Dremio has a feature called reflections. And reflections essentially are like materialized views, but they can have their own separate partitioning rules. So if I have like three different columns that I want to optimize for, what I can do is I can create a separate reflection for each that partitions based on each column. Okay. And the beauty of this is that when the original data is Iceberg, Dremio's reflections have two new features that really minimize the cost. One, updates are incremental when the source is Iceberg. And two, there's live reflections. So whenever the underlying Iceberg table updates, it'll automatically update the reflection. So you end up getting these really quick, really fast, cheap updates to those materializations. And then what happens when queries come into Dremio, Dremio will just select the right reflection for the particular query. So the end user just queries a one table, and they don't need to realize that there's, hey, these three reflections on there. Dremio will handle which reflection should be matched up with that particular query if you need it. And then that way, if the query isn't part of your typical query patterns, you can still just use the original table that might still have like less files. Because again, there's also the scenario where you optimize so much for certain queries that the original tables slice up too much for general queries and makes it slow for those queries. Like someone does like a select all or something. So those are just some of my thoughts there. Again, I have written an article recently on it. At the end of the day, it just comes down to knowing, hey, what are the queries you have, and try to think through balancing the number of partitions with the amount of data that's going to be in those partitions. And sometimes that does require some experimentation. And that's the beauty of partition evolution. You can change the partition, see how the data writes. If you like it, keep it, and then keep evolving it from there. Or what you can do is before you migrate a table over to Iceberg and you're trying to decide how you want to partition it, do a subset of the data, let's say like maybe like a gig's worth of data or something like that, or a few gigs worth of data, and try different partitioning schemes and see how the files lay out and see what the distribution of the size of each partition is, which you can use the metadata tables to inspect. And then from there, kind of see what's the best. Again, I think if you are using Dremio and you're leveraging reflections, then the thought process there becomes a lot simpler. Because you can just stick to historical partitioning for the raw table and then use reflections for your other partition. Cool. Okay, I want to partition based on date. When I try to read the data, it has an option to provide the catalog of the table. When I use the select query clause on the partition column, or do I need to use Spark SQL to use? Okay, I want the partition table based on date. When I try to read the data, it has an option to provide the catalog table. Can I use a select query with the where clause on it? I mean, you should be able to use any SQL with any tool. Like bottom line, the whole point of Iceberg is for you to be able to take a table made with tool A and be able to write all the SQL and analyze it on tool B because it's the same underlying format. Now, and generally that's why even the partition transforms are standard. So basically, every tool is going to allow you to do bucket, truncate, day history, hour, all that kind of stuff. So you don't, there's nothing that you have to do with Spark SQL. Now, Spark SQL is oftentimes the default just because so many people use Spark. So it becomes sort of like the default processing tool. But the beauty of Iceberg is that it's not the only processing tool. And, and again, as you'll see in the next episode, we'll show you doing a lot of these kind of workloads with Dremio. Okay, so as far as I can tell, that should answer that question. Suppose I have created an iceberg table with partition based on column A. Can I change the partition later to column B without rewriting the data? 100%. That's 100% the point of partition evolution. Now keep in mind, when you switch it over, all new data will be partitioned based on column B. All the old data will still be partitioned on column A. Okay, so essentially, going forward, anyone who's sending in queries based on column B will have a faster way of scanning the newer data, the data that's the data that's since the change. And then maybe there'll be a little extra latency on that older data because that's not partitioned by um, column B. But you can determine whether that's worth rewriting. So again, you can use the rewrite procedures. You can use the optimize command in Dremio to rewrite that data if you want. The thing is, you don't have to. That's the beauty of Iceberg. So for example, if it's just a small bit of data and it shouldn't affect the latency of queries going forward much, then why bother going through the rewrite procedure? The cost of rewriting lots of data for what might be a minuscule performance update may not be worth it. But if like the two query patterns are very diametrically opposite, and there's queries that don't need that old style, then maybe it's worth going back and compacting it. And when you compact, it will rewrite it to the new partition file. But the thing is that you can make those decisions. You don't have to. You're not locked into having to rewrite, and that gives you the flexibility to kind of decide to give you more flexibility to decide what is the right way to go forward. Cool. Okay, how costly is repartitioning? Can we easily partition and repartition data, or does it require some costly calculations? I mean, basically what happens if we were to break it down at a high level, if you were to repartition, with Iceberg, repartitioning the data costs nothing because at the moment that you change the partitioning scheme, no data has been rewritten. Only the data going forward gets written in the new partitioning scheme. Now, let's say you want to go back and rewrite the old data in the new partitioning. It depends how much data there is. Okay, if you're talking about like a couple gigs of data, probably not a big deal. But if you're talking about petabytes of data from several years, that can be a really long and a really expensive rewrite. Okay, that can take a lot of time, and you may not necessarily want to do that right now. You may want to do it, but you may not want to do it right now. You may need the repartitioning to kind of update your pipelines coming in because you want the new data to be written to the new partitioning scheme, but you maybe want to incrementally update the old data. Okay, so that's another benefit of this. So for example, if I've been partitioning by year for several years and then I suddenly switch over to month, I still want the new data being coming in as month. So all the new data is coming in and being chopped up by month. But what I can do is instead of rewriting the last 3 years worth of data in one shot, what I can do is I can do them in separate jobs. I can say, hey, year one, let's rewrite one job this week, and then next week we'll rewrite year two, and then following year we'll rewrite three. So that way I can chop up my jobs. So that way it's not blocking other work or zapping up too much of my resources. So a lot of times you may want to rewrite the old data, but the benefit is when you don't have to, and you can do it incrementally. So you can more intelligently rewrite the old data step by step versus having to kind of do it all at one time and then either hit the cost of doing it all at one time or the resource drain of doing it all at one time. So again, it just opens up a couple different new worlds of flexibility you wouldn't otherwise have. Okay, we answered that. Can I use the partition date as of date for time travel? Is there an option to achieve? Well, okay. So basically, the way time travel works, it's not based on any column. Okay, so it doesn't matter what the values of any particular column is in the field. It's going to be based on the timestamps within the metadata for each snapshot. So each snapshot is going to have a timestamp on which that snapshot was created. So when I do an as of query and I say, hey, as of a timestamp, okay, what it's going to do is going to find the snapshot for that particular timestamp. Okay. And then when it reads, it's going to use the metadata as it was at that time. So if the date, if I was used, if I changed my partitioning like 3 times since, let's say, so basically I have partitioning scheme 1, 2, and 3. If that older snapshot was written with partitioning scheme 1, that's what it's going to use. Okay, it's going to use those data files from then, assuming this is all a valid snapshot. So that means all those data files still exist. It's going to use all the data files that were associated with that particular snapshot that were partitioned the way that particular snapshot understands. Okay, so it wouldn't use the newer data files that were rewritten because those are not part of that snapshot. Each snapshot has its own separate list of which files are part of that snapshot. So in that case, when you scan the older snapshots, you would be using the older partitioning on the older version of the data. Now, there's no way like to cross it. Like I can't say, hey, apply the old partitioning to new data. No, it's all based on sort of what is the settings at that particular time. And then that snapshot is written based on the data files that are currently available from previous writes and the new data files that were written from the current write. And then that's all wrapped up in the metadata. So that way, and then you can understand that particular snapshot that was made at that particular time. And then I can say, hey, as of this timestamp, and it'll find the snapshot that is at or before that timestamp. Okay, I'll give it another few seconds to see if there's any other questions. Okay, but with that, what I would like to do is just remind you guys, go check out that article that's on the Dremio Medium blog. That is the ultimate resource guide for Iceberg. So that way you can find literally all the different blogs and tutorials all sort of nicely categorized in one place. Check out a lot of the recent stuff over there at the Dremio blog. We've covered CDC, tutorial on how to use the REST API with Messi and several other things. So there's a lot of really kind of good stuff to kind of get hands-on with over there new on the Dremio blog and the Dremio Medium blog. There's been a lot published over the last week. So with that, again, continue keeping an eye on the space. If you don't already follow me on LinkedIn, follow me on LinkedIn. I'm constantly pointing out Iceberg resources. Thank you guys for coming to this course. Once again, we will share the on-demand within 24 to 40 hours. Otherwise, have a great day and enjoy, and thank you as always.